Good afternoon, everybody. So this is Wolfgang Gensch from the UberCloud. And I welcome you to the webinar. Looks like Sai is already playing around. 1 second. Okay. I see Sai's. So I really want to start the webinar on his side. And okay, so let's start. Welcome again. And this webinar is about EGI Cloud for SMEs in computer-aided engineering. And it starts with an introduction to EGI and the EGI Federated Cloud. And then we will have a demo, which is OpenFOAM in a container, in a software container, which is quite novel technology, sitting on Chestnut in Prague. And the OpenFOAM example has been provided by Lubos Pirkel from CFD Support, sitting also in Prague. So without further ado, let me try to switch the moderator to Sai Holzinger from the EGI Foundation, who is the senior strategist and policy officer of the EGI Business Outreach, and also joining Giuseppe La Rocca from the EGI Foundation, who is the technical outreach expert and who has helped us to implement the container on the Chestnut cloud resources. So, Sai, are you on?
Yes, I am ready.
I hear you. Yeah, okay, good. And we see already your screen.
Yes.
So I don't have to move it over to you, but is it already your presentation modus?
Yes, I'm in ready to go.
Please, then. Okay.
Well, thank you very much for Wolfgang for the introduction and also the support in putting this webinar together, and for all of the attendees who's taken the time to join us for the next hour. So as Wolfgang said, my name is Sai Holzinger. So I do a lot of strategy and business development for the EGI Foundation. I am also the business outreach manager. So I'd like to thank also Giuseppe La Rocca, who's supported the technical side of getting the OpenFOAM container up and running. So basically, I just want to give you, for many of you who I've seen seem to be quite new to EGI, so I'd like to give you a brief overview into who are we, how are we organized, and what do we offer. I'll specifically cover some services and some points, some value that we think we can offer specifically for SMEs, and then give you a brief introduction to the EGI Federated Cloud service without going into crazy amounts of technical detail. And then we'll pass over to Wolfgang so he can show you how all of this kind of works in practice. So what is EGI? So EGI is basically advanced computing for research. So we deliver exactly that. Computing services to support scientists, researchers, multinational projects, research infrastructures, and as well as industry. So we are a publicly funded infrastructure that's supported by the European Commission, national funding agencies, and also who are our main customer base, but also what we want to do is try to make this infrastructure of value and of use for industry, commercial organizations, and specifically small to medium-sized enterprises. So what then do we offer in terms of our service catalog? Well, our two main principal services that we offer are compute. This is both cloud compute, so running virtual machines on demand, cloud container compute, so Docker containers, and then also high throughput compute, which several years ago was known as grid compute, which is basically just batch processing of thousands of computational tasks to analyze large data sets. And then to complement the compute services, we have storage services as well as data management related services. So online storage, so you can share your files and your metadata on a global scale quite easily and quickly, and then along with archive storage, which is more for your backup your data, your long-term and maybe potential future use, and then data transfer. So then you can transfer large data sets from one place to another. So then to complement these kind of core services, let's call them, we do offer some training and consultancy. One of them is in around a standard for IT service management, which is called FedSM. We provide formal training and certification courses and consultancy around its implementation. And then as well as we have an infrastructure that's available for training and education. So this is pretty much the EGI services in a nutshell. So taking a step back slightly broadly, so EGI, we're a European federated infrastructure, so we span more than 50 countries. We've integrated more than 300 different resource providers, and together we offer more than 100,000 cores of compute capacity, 560 petabytes of storage, and we serve almost 50,000 researchers at the moment. So then how are we organized? So my organization, the EGI Foundation, we are the coordination body. We have a headquarters in Amsterdam, and we are supported through the EGI Council, which is a representative of 22 major national e-infrastructures, which we call NGIs, as well as 2 European international research organizations. So I think most of you have heard about CERN, and then also EMBL in the UK. And they pay membership fees or participant fees on a yearly basis, which helps support the glue services that federate these different countries into a single e-infrastructure, as well as the coordination activities that we perform within inside of the headquarters office. So here you can see a little bit how far EGI has reached. So again, we're pretty focused on Europe, but we also expand through peer infrastructures in the US, Latin America, South Africa, and in Asia. So over the last year, we've instantiated about 250,000 virtual machines. So for the batch computing, the batch processing jobs were about 1.7 million per day. And this totals about 2.6 billion CPU hours a year. So it's an infrastructure that, let's say, gets used on a daily basis. And we are growing. So I think this is one of the important messages to convey, that yes, EGI itself was established in 2011, but the technology and the services have been running for more than a decade, from proof of concepts to now what we see as a long-term operational model for the infrastructure. So we continue to expand and grow with each year. So that was pretty much the overview of EGI. I'm happy to take any further questions later in the webinar should you have more. But I think the most important thing is to say, what does EGI offer for SMEs? Or more importantly, why would a public entity support SMEs to begin with? Well, I think this kind of breaks down to a couple of different areas. The first one is basically the European Commission has made SMEs one of the priorities of their policy for leading delivery of innovation to the market. So they've given us basically the mandate and also the support, whether through policy or through financial resources, to then make the infrastructure available for SME use. SMEs are also the leaders in innovation and economic growth, and I think that's one of the key missions of EGI, is to stimulate innovation and research, as well as social and economic impact. So basically, if EGI can show or demonstrate that by public investment into the infrastructure has had an impact also in the private market, which has made, I don't know, a new business exist or expanding a current business in which they were able to grow and employ new employees, etc., then that's a major, let's say, result for the infrastructure and for EGI as a whole. And then obviously, let's say the less tangible things is that EGI has decades of experience in running and operating compute infrastructures, so we can share our expertise. However, there's also a plethora of knowledge within inside of the commercial area that I think many of the researchers and the academics can learn from as well. So there can be an exchange of knowledge and services. And then as well for EGI as a whole to create new business opportunities. So basically industry comes along, they try out the infrastructure, they're building on top of the infrastructure, they like it, and we want to implement, let's say, long-term business relationships. Then that also kind of can generate business opportunities for EGI as a whole to ensure the long-term business operations of the infrastructure. So more tangible, we've kind of broken what we offer to SMEs down into kind of 4 key categories. The first one is, I think, probably the most interesting one for the people on the call is access. So access to the infrastructure itself. So whether it's to run pilots, using the resources, running proof of concepts of new potential services or capabilities that the business is trying to research or to develop, all the way to, like I said, to paying for the actual resources whenever we get into the long-term business operations. But it's the key message here is to stimulate the use and the research and development side of it, and then once we've established this works, this is the long-term model, then we can move into more business operations aspects. Another one could be is that EGI has the principle of making results as open as possible. So we publish within inside of a marketplace that we call the applications database, or AppDB for short, where you can find research data sets, tools and softwares, applications, and also, let's say, cloud virtual appliances, anything that you think could be anything that could be reused. This way, then you're not always completely starting from scratch from everything that you do. Then we can move into more hands-on or collaborative areas, which is something to co-design. So we pull together from the wide network of expertise that we have throughout EGI that has experience in either the dedicated inside of the technology that's being used and the type of application, etc. And we're able to pull together this expertise to co-design together either new products, services, or functionality within inside of the technology. You can integrate with EGI because basically EGI offers an infrastructure as a service that you're able to build on top of. So now we can get into platforms as a service, software as a service running on top of EGI, so you can integrate with us. And then also, like I said, share the expertise. And then finally, marketing. So SMEs, small businesses, have most of their resources dedicated to the development side of things. And it becomes very difficult to get marketing and promotion and things outside of your existing customer base. So EGI having such an international reach can offer visibility and marketing opportunities, whether through promotional material, joint articles, and also event participation. And then this also then builds into networking opportunities, so meeting new people and getting together with like-minded people who are potentially working in something that could be potentially interesting for you. So we have already been doing this, and this isn't something completely new to EGI. We've been working with a number of companies over the last several years. Like I said, whether it's platform integration, so there's a company, Cloud SME, offering simulation platform for manufacturing and engineering. EGI sits on the back end of that. TerraDue, who works in areas of Earth observation. We have customers who are just simply using EGI's compute services along with dedicated support and consultancy. We have the business development activities where we partner with organizations such as UberCloud, which I think you guys will see a nice demonstration of this. We get involved in large public-private partnerships. We've teamed up with people for like our training, our FitSM training. So we have a certification authority that provides the certificates for our training, so TÜV-SÜD. And we also have a commercial provider, 100% IT from the UK, who's part of the Federated Cloud offering cloud resources. So it's just to give you a couple examples of how we're already working with industry. So this last bit with the remaining couple minutes that I have left to talk about, which is the EGI Fed Cloud itself. So what is the federated cloud? So I think it can be basically viewed as a cloud of clouds of sorts. So we have a number of different providers who are offering their own cloud resources, in which EGI then puts them all together through unified user interfaces. So the end result is you have a harmonized operational behavior between through the federated cloud, even though it uses multiple cloud providers. All of the clouds and the interconnections in the next slide gives you a little bit more detail about this, but they're all based on open standards and open technology. So the idea is that we can provide as much flexibility to the users in how they interact with the infrastructure or how they use the infrastructure. So then basically then this opens up two different modes of operation then for how a company could interact, or any researcher or end user, is you can access the infrastructure, so consume the resources and consume the services that are made available, and from a technology point of view where you can deploy on top of the infrastructure. So we try to make it through the open standards, make it easier to integrate your platform or your software on top of EGI through APIs, etc. So then what does this then look like? So we have 22 providers, 14 NGIs, which are those major national infrastructures that I mentioned before. So 15 of them offer OpenStack, 6 with OpenNebula, 1 with Zenefo, but we aren't limited only to these. It's just the current providers that are offering the services through the Fed Cloud, and then the 100% IT, which is the one commercial provider. So this is a collaboration of a number of different providers who are developing, innovating, operating, and using the cloud federations for their research and development, their research and innovation. So this is in line with how commercial organizations would like to run proof of concepts, etc. So a little bit more about the standards that we're using. So for the virtual machine and block storage management, every single site has a OCCI interface with it. So and then on the OpenStack sites, they're all using OpenStack. So however you're accessing infrastructure, what this does then is ensures that we hide all of the complexity on the back end, so you're not dealing with it. So whether you're accessing through an already existing portal or application or user interface, having these standards based on the back end hides then all of that complexity. So then this leads to a number of different services like a cloud registry, information systems, we have the VM marketplace, there's usage accounting, and then we can also provide access control as well. So what do we mean by then access control? So access control is provided through a mechanism what we call the virtual organizations. And this is how we manage to group people together, and we assign, you'll be a virtual organizational manager, so then you can control if inside of your organization you want to control which members of staff get access, what they're allowed to do, etc. We're able to create these dedicated environments specifically for you. So the types of tools and services and software in which you want to use, we create the individual environment for you. And this access is provided through digital certificates, so X509 certificates. And we have a number of different virtual organizations that we set up. So generic ones, so for incubators for new services, services. We have sector-specific ones, so dedicated environments. So like a lot of times, individual sectors like manufacturing or engineering, or whether it be biology or life sciences, whatever it is, they all tend to kind of use similar tools and applications, and by grouping them together, they're able to work together in a more harmonious way. And then finally, we have the training view, which can be basically we've set up for you guys to check out the simulation, which will explain the instructions later in the webinar about how this works. So your typical usage models, you have your compute, your data-intensive workloads, so batch and interactive, the cloud containers, so this is Docker supported, as we mentioned, service hosting, so long-running services, web server, database, application service, data sets, repositories, so you can store, manage large data sets in a storage volume, disposable and data testing environments, so you can host training environments, test applications, etc. So it's quite a dynamic infrastructure and environments to use. So that's pretty much all that I had with the overview of what is EGI, what can we offer SMEs specifically, and then a brief introduction into what is the Fed Cloud. I think it may be better once you start to see it basically in practice. So I think we're going to save all of the questions and answers. You're more than welcome to put it here in the control panel that you see. There's a spot there for questions if you guys want to type out your questions, that we can collect them and handle them at the end. And so with that being said, I'm happy to pass back over to Wolfgang and have him show you what all of this looks like.
Yeah, thank you very much, Sai. Very nice. Would you hand over the moderation to me?
I will do.
Okay. Looks good. Yeah. So that is let me just check one. So that's my first slide here. Okay. Again, hello everybody, and Sai, thank you so much for your nice introduction and overview of the EGI infrastructure and services. Next thing is that a few days ago we have implemented an OpenFOAM software and an example on one of the EGI cloud resources. We selected Chestnut in the Czech Republic, and we selected as the OpenFOAM software the one from CFD Support, which is sitting, in fact, by chance, also in Prague. And they offer what they call OpenFOAM Inbox. And we have selected and prepared an example for an airfoil, NACA 4412, quite standard airfoil here, which we use for demonstration. So let me just go quickly through the how you approach this. So either you go to the EGI website and request a certain service, or there is the other option that you go here to the UberCloud marketplace, and then you look at, for example, EGI. That is the store of EGI, as you know, in the section of the cloud providers. And you see here several services like EGI Cloud Compute, Cloud Container Compute. That's a difference. This one is sitting or has to be implemented more bare metal as you know, service infrastructure, and the container one is ready to go. So it is the whole stack from the resource infrastructure up to the application, which is containerized and ready to use. And so that's what we want to demonstrate now to you. So when you click on one of these services, you get a welcome email, and which says, okay, thank you for joining, blah, 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 etc. Your compute environment is now ready, and you have a link directly to the container which is sitting on Chestnut, on the Chestnut cluster, and then you copy paste this password, and then you click on login. So so I get to this. You might have recognized this EGI UberCloud.net, and then I get this login window. I already copied and pasted the password to be fast here, and whoosh, you're already sitting. Let me just minimize that. You're already sitting now in the container. While this is running, I will explain you a little bit more about the containers, but for now, let's simply start a job. And I mean, you easily recognize that, hey, this looks really like my own desktop. And that is really intended because all the engineers we're working with, they requested that getting them to the cloud should be as simple as getting them into their own desktop, local desktop workstation. So this was a real demand from basically all of our 190 plus engineering collaborations, engineers with their real applications into the cloud and taking results back then. So you see, I mean, you see one thing here. So this is what we currently have available on Chestnut, and a nice, quite impressive thing is really that everything is interactive. Right, so you can really interact even with the cloud, with to be more concrete, with the resource your application container is sitting on. So certainly not looking into the whole cloud and any resource, but it is bare metal dedicated resource just for you, ready for you, and nobody else is sitting on that. So questions like security, etc., they don't arise easily. So that is that one. We will look back into it again when we do the calculation. So the terminal window, which I open, and that's what you just saw there. I just ran a test application before the webinar, and so I run another one. As you see, it's immediately running. There is almost no delay, and you see running solver simple foam. And while this is running, I mean, as I said, we just can look into, and you see all the CPUs are now fully busy. So they are, this is a parallel implementation here. And you see, full utilization of all the resources, which is kind of nice. So we get back to that one. So let me just now get to my presentation for you. While this takes about 4 minutes, it is 6 time steps, and so we stop it there to just look at the intermediate results graphically. Okay, so now let's get into presentation mode here. And in short, that's what we do. We take engineering and scientific applications embedded in software containers to any computer, be it a workstation, be it a server, or any cloud. And it is fully portable, so you package it once and then you can port it anywhere. So very quickly, we started in 2012 with building this engineering community, and in the meantime we did 190 plus cloud experiments with engineering applications, and we helped engineers, and together with them we wrote case studies, published them, to create this community, to start speaking one common language, namely HPC in the cloud. And after that, you have seen the online marketplace we have built. And then, over the last 3 years, we developed these HPC containers, starting with the base Docker container, which was made for microservices, and we turned them into what we call macro services, basically real heavy engineering application software, and even whole workflows, from pre-processing to post-processing, including several solvers, embedded in an optimization loop, for example, and so on. So this can all sit in one container. You close the container, and you can encrypt it, you compress it, you store it, you put it on the shelf, and whenever you need it, you take it back, and you can move it to, as I said, any cloud. These are Linux containers, so they run on any form of, on any Linux, and they can host any software application like the one here, as you see from CFD support. but in the meantime, we have over 30 CAE containers, and they run in clouds like EGI, Advania, Amazon, Microsoft, Böhl, Atos, CPU 24/7 in Potsdam, OpenFOAM in the US, and so on and so on. We have very strong partners who are interested in this technology and who take us to their customers and into their environments as well. So very quickly, benefits, because we didn't talk about that, to just remind you that this is not just for fun, but it's a real benefit. When done right, then it is of real benefit for you. So obviously, whatever you have on your desktop, in the cloud you find more computing resources. There is no upfront, acquisition by big resources, etc. No upfront capital expenditure necessary. It is on-demand, pay-per-use, and available, as you have seen already, at your fingertips. You can scale resources nicely up and down, and you have the choice with multiple providers, which means you have a choice with multiple architectures. Depending on your application, you might select a provider which has InfiniBand interconnect when you really need low latency, etc. But for some applications, also Ethernet is sufficient and might be a little bit cheaper. And we basically summarize it under better, faster, cheaper. There are also cloud challenges. The most important challenge these days, it's new for many engineers. There is the concern that they have to learn something new, that they need to, to get to the cloud, they need to do many steps, and it might take time, etc. But with the containers, which you already have seen, everything disappears in that regard. Security and intellectual property in this context is not a real issue anymore, but because the container is yours, the resource which the container is sitting on is yours, so there is no multi-tenancy, there's nobody else using your resource and potentially sneaking into your container, which is not possible. Traditional software licensing is history, basically, because most of the cloud providers currently are already offering short-term licenses, which are ideally suited for the cloud. Then there is heavy data transfer, and there are means in the meantime, like accelerated GPU-accelerated data transfer with software like NiceTCV and others. And next one here, cloud expertise was needed until recently. Okay, if you go to plain infrastructure providers and have to implement your software your own, have to build your own cluster, okay, so then you need some expertise on that side. But again, so full-blown complete solutions from hardware up to the application level is for them that this is no longer necessary. Very often you lose control. When you hand over your batch job to a cloud provider, then you don't know where it really runs. But in our example, in the container you have even a monitor which tells you exactly not only the resources but also the usage of your resources. And so let's quickly look at these challenges which containers remove or reduce: security, portability, compliance, data transfer, standardization, etc. So there is an article on our website about that, and if you want to know more or you want to read this article, just send us an email, please, because that's a long story. So this is the URL, but again, just send us an email. It is about workstations, servers, clouds, comparing apples to apples. And you'll find it even if you type apples to apples or something like that and UberCloud into it, you will find the article. Okay, so we will quickly show this demo from the browser of your local desktop. You go to the marketplace and then you receive this welcome email with the login information and you get into the container. So let me again just go back and let's see what happened with our container in the meantime. You say, okay, I'm sure you see the container and you see the terminal window and it says all run sh. So we are happy. It seems to work. What we quickly do now is we do a parafoam command. So I want to type it slowly so that I don't mistype it. Okay, you see ParaView immediately popping up. And please imagine, I mean, I'm sitting here. This time I'm sitting in Regensburg. Let's see what our CPUs are doing. Okay, this is more or less system noise here, okay, so that's nice. So my browser goes to some internet provider, goes to Chestnut resources in Prague, and the results are coming back. So just for your information, to see how fast this really is. So we did 6 time steps. So I want the results of the 6 times. At the end of the 6 times, I apply this here, and immediately you see the computational domain. It has to be large, otherwise the airfoil would interfere with the boundary conditions too much, and especially when it comes to transonic flows, shock waves from the airfoil would be reflected from the boundary condition and get back to the profile, and so that's disturbing the physical solution. So that's why. But I zoomed in, as you have seen, and for example, I can see, say, the mesh for which the engineer put together beforehand. I can zoom into the mesh, and you see, I mean, it's really almost identical to the interaction which you have with your workstation. So you can zoom in and study, you know, how fine the mesh is for the boundary condition, for the boundary layer. Sorry, this is physically here. So let's get back into reasonable size, and so what we let me get to surface mode again here and go to the physics. So very quickly, and it's only really not to discuss the physics with you here, but just to demonstrate that this interactive work, which is really basically unique for these containers, you know, on-demand access interactively, and then working with your results, doing so. Pressure here, for example, immediately the pressure pops up, and for those who know CFD quite well, you see this is about a 30-degree angle of attack here, because pressure is high here in underneath and lower here on top, and resulting in this drag. But we also can have, you know, like velocity, for example, if you like, and so this is velocity. Obviously, very similar in understanding. Velocity is high here, low there, etc. So I think this is already the demonstration. So I showed you the whole process of getting into the container, starting a simulation, getting the results, you know, monitoring here your CPUs, their activity, you know, with an unbalanced work of CPUs, you might find, you know, some errors in, for example, your parallelization and so on. So let me get back to so to the presentation mode, and I think I hand it over to Sai again. Let me just check. So Sai, are you able to take the control back yourself, or?
Yeah, I can take it back.
Yeah. So thank you very much for your patience. I give it over to you. We still have 20 minutes. 20 minutes for discussions and so on. Great.
Okay. So basically, then the question is, what now? How to get started? What do we do? So there's 2 aspects here. There's basically what do we do now in the immediate with the OpenFOAM container, and then what can we do with EGI if everything that we've heard over the last 45 minutes was super exciting. So the first one is basically to test the OpenFOAM container. So we are going to organize, basically make available individual 24-hour time slots to be scheduled following the webinar for any of the participants who are interested to go in similar to what Wolfgang did and to play around with the OpenFOAM container. We've made all of the instructions available on like a wiki page, basically, but it's just to send us an email at business@egi.eu and to request the credentials, and we'll give you your own individual password for you to then access it over a specific period of time. And for anybody who's interested, this will be made available to you. So the instructions are, Wolfgang, are we making these slides available online? I believe so.
So definitely,
Okay.
I'm also recording this.
Okay.
So yeah, so we can upload it on some of your pages and send an email around afterwards to all the participants.
So the link is here. It's go.egi.eu/OpenFOAM FedCloud test, and find all of the instructions for how to take that forward. Then the next part would be basically then starting to do basically business or collaborate with EGI. So for anyone interested in continuing to work with EGI, basically we ask for a very simple introductory questionnaire that we have that helps us to kind of understand who you are, what areas that you're working in, and what would be the collaboration opportunities that you see moving forward. Or you can just simply send us an email at, like, it's the same address to get the credentials, which is business@egi.eu. So basically, we have a dedicated team within inside of EGI. We do an initial assessment of the collaboration opportunities. We then assign, depending on what you want to do in what area, we assign individual contact points that match your request with the best solution, and then we carry on the activity. So it's very customized, it's very tailored to exactly what you want to do and what we can offer. This way we're maximizing value of everybody's time on both sides. So this is pretty much the process that we have. We try to keep it as lightweight as possible. So if you have any questions, we have several people behind this that can answer them for you. So that's pretty much it. We will basically, I think we'll moderate the question and answer section by basically raising your hand by hitting the hand button next to your name, and we'll unmute you, and you can ask the question, and we can answer them on the fly. And then with the last 5 minutes of the call, we basically just do a post webinar survey with you, and that's it. So I mean that's all I have from our side. So I'm really looking forward to basically answering the questions you may have. So I think Giuseppe was the first one. So we've unmuted you, Giuseppe.
Thanks for the presentation. It's very interesting. Giuseppe Padula, I'm calling from University of San Marino, and I'm part of the Cloud SME project. And I wanted just to know how was the collaboration with Cloud SME, and how you forecast also possible future collaboration with this project that I see very much interesting.
So I guess I can take this one because I'm the lead contact on that collaboration. So right now we're in the technical integration process at the moment. So there was some initial tests to make sure that they would be able to access one of we used a specific one. It was Chesga in Spain, and they set up a quick little testing environment to make sure that they were able to access the resources, and from a basic test point, everything went fine and it worked quite well. So right now we're looking into the technical integration of the full platform. So this is ongoing. The the original Cloud SME project, as you know, finished, and they created the company, and they have a follow-up project which starts at the beginning of January, if I'm not mistaken. It's called COLA. So we're hoping that basically through some financial support through that project, we can speed up the final bits. So we're at the analysis stage as well to expand out from current testing. So from my point of view, I think it's quite positive, because I think Andreas and Thomas, the two lead contacts that I have on there, are quite dynamic and practical people. So I'm looking forward to be able to eventually for them to deliver to their customers using EGI resources on the back end. So I hope that answers your question.
Yeah, thanks.
One of the biggest things, just to finish, one of the biggest things to work out is once we have, let's say, the full mechanisms in place to define what will be the exact business relationship moving forward. So
yeah, so there are two more remarks. So one, someone said he has to leave and was asking for the slides. So we already answered that one. And the other one I got through the question section directly is, do I have a choice of one of your many compute resources? For example, demand a resource in Germany, and how would that work? So just to clarify, I think, as I mentioned, currently we have implemented the OpenFOAM container on Chestnut resources in Prague, and but the rest of the question, Sai, is for you. I think is better for you. If someone is really requesting, I need access to resources, you know, for example, for some compliance reasons, you know, so they cannot leave the country, for example, etc. How would that work?
So this is pretty common. I think this is why I believe the second question of our initial questionnaire is basically what country are you in, and if you're interested in working with basically a specific provider in that country. So we really try to hammer this down. If this is let's say one of the requirements, then EGI works together with our providers inside of that specific country in order to deliver what you needed. But this is, I think, one of the advantages that EGI has, is that we have European coverage and then beyond. So if these are specific requirements that a specific customer has, then we're able to meet that requirement. So yeah, country specific is not a problem.
Mm-hmm. Good. And here's another written question in the question section, which is how secure is this environment? Okay, so that has to do with security. I can start, Sai, if you like, but then,
yeah, and then basically, then you put in your 2 cents, and then I let Giuseppe continue. So.
The other 2 cents.
Yeah.
Okay, so let Giuseppe talk about the security of the infrastructure, because that's up to you guys. You know, kind of the security of a data center, of one of your data center partners, etc. But on our side, the application software and the data and all the tools, so as I mentioned before, the whole workflow is sitting in a container. This container has one very strong security feature, because, so number one, it is sitting on one dedicated resource. So depending on the number of nodes, so you can build your own cluster, 1, 2, 3, 4 nodes or so, 64 cores, whatever, and that resource belongs to you in a dedicated way. It is bare metal. The container is sitting on bare metal, and then it has these 30 plus HPC layers on top. You can encrypt your data transmission back and forth. Also, what you could do what we have done recently for someone in North America for a company is we have established a virtual private network. So on the end user side, this requests some VPN hardware, a card which you have to buy once, and then you can connect anytime you want. So that is an end-to-end security, which is as secure as any of your local security measures. Okay, I hand it over to you.
Can I add something here?
Absolutely, go ahead,
Okay.
Giuseppe.
So for what concerns the security in the cloud environment, basically, as mentioned before by Sai, we use the digital certificate. So this means that all the virtual machines that are started in the federation are secured using this digital certificate, which are released by Trusted Certification Authority. So there is additional level of security here. So in the first step, basically using this certificate, we deployed this virtual machine with Docker container, and on top of this virtual machine, people from UberCloud deployed this HPC container that was demonstrated today by Wolfgang. So you need basically this certificate before to start any activity on the provider exposed by our federation.
Okay, great. So as you see, there is another question here. There are more coming in, and so we want to hurry a little bit with. So hi, I'm from an ISV. We would like to offer our SaaS on demand, software as a service on demand, using EGI platform. We are partnering with UberCloud. We have done some containers with UberCloud. How users can book an on-cloud session on your site, including payment, getting access, etc. So if you want to, okay, so the question in short is, can a software provider establish, an application software container on one of your resources or on a few of your resources, and offer the software as a service, the SaaS offering then on demand to users? And how, I mean, that's a specific additional question, how payment then would be handled.
So I guess
yeah,
I could
probably
take this one.
Mm-hmm.
So the short answer is yes. The long answer is it depends, because we do need to remember that EGI is a publicly funded infrastructure, and it needs to be very careful on simply offering what is available already currently on the market, because then you get into state aid and competition laws with, for an example, with Microsoft Azure and Amazon Web Services, etc. So we always need to analyze the use case to basically understand what does EGI provide that you may not get onto it, or is this purely to support, let's say, research and development aspects. So there's a slight depends here whenever it comes to it, but from a conceptual model, from a payment model, from a usage model, all of that is definitely possible, because that's the point of EGI, is to allow people to develop on top of it. We just need to look specifically at the use case and what it's being used for and how, and if this is a use case that EGI can satisfy. So I hope.
So what I understand from you as an example, Sai, is that a software provider can upload its software as a service, and for example, serve researchers, so serve the research community, for example, in Europe or even worldwide. I don't know. Would that be a use case which you know that it is
most
acceptable?
definitely. This is something similar that we do for a commercial provider, the one that I mentioned before from Earth Observation. So they offer a commercial simulation, and so it's an application to be able to visualize, manage, and read and consume data that's coming from the European Space Agency and satellite systems that are coming. So we do work with a software provider, a platform provider, a commercial one, and we are basically in the process negotiating how part of those services would be paid for, so paying for the resources as well. So we do have examples of these models being made available. So the payments aren't the problem, and it's the application and what it's being used for and how. So as soon as we basically understand that, then we can put together all of the pieces.
Great. Any other question? Let me check the participant list if we see a hand raising.
I see another one. Would you be open to collaboration with the commercial independent software vendor? So
no, that's
the answer is yes.
Yeah. That was that question. Yeah.
Will it be limited to research and development projects only? Those are, let's say, those are the majority of the cases. So the short answer is yes, but not necessarily limited to. So I think if you find the EGI being of interest, then we should really follow up offline to understand what we can do together and how. So because I think you have some very interesting ideas that we would be definitely want to explore on how we could support them. Which is the point of this, is to basically stimulate the ideas.
So let's go back to the list again. And time is almost over.
Yeah, so I would really like to kind of get you guys' short feedback. I know we've only had an hour together, but hopefully then we can continue offline. But I'd really like to kind of get your feedback. If I could, I believe you guys have the chat window to be able to put this link in the pool.
So I have a chat window. Hopefully everybody else has a chat window.
Send to all.
So you wanna give us a link?
Yeah.
Okay. I see you copy paste. Yeah, you want to copy paste that? Okay. Here it comes.
Can you guys?
Holzinger. So we click on this link below. It says 16:58, which is the time, and you want to ask us a few questions or one question or so. It is Slido or Slidos. Yeah. Okay. I see.
Hopefully.
Interesting. There are two more questions. How do these questions come to that? Interesting.
So I have unmuted everyone. So can you see the link that I've circulated? Has everybody got it? You should be unmuted so you can tell me yes or no quite quickly.
Yep.
Okay, so the first one is basically how overall how satisfied were you with the webinar for the time that we had together.
Interesting. So
switch over my screen. So we can live see the results as people are coming in. Got 8 so far. I'm going to close this in a couple seconds so we can go to the next ones, and we can close off this in a minute or two. Eight out of the 12 is not bad. So let's move to the next question. So what would have made you fully satisfied, basically? So what were some of the things maybe we could improve for in terms of information presentation, the structure, the information for maybe if we organize the next webinar showcasing something else? If there's anything you guys would improve? A good one.